Hey everybody, hope you had a great weekend. Today we're going to continue talking about graphing radical functions, and we are going to talk about transformations. At this point, I think you guys are pretty much experts when it comes to transformations. You can probably do it in your sleep, but we'll go over it again just in case there's anybody that forgot anything from any of the previous times that we've done this. So this is the same as any other function transformation that we've done, it's just now it's in radical form. So instead of dealing with parentheses, we're dealing with radical signs. So if we're talking about horizontal translations, if you see the function is f of x minus h, so if you see minus, it means it's to the right because h is positive. If you see plus, it means that h is negative, which means it's to the left. If you're adding outside of the function, so if you have the radical and then you're adding outside, then it's going up. If you're subtracting outside, it is going down. If the x on the inside is being multiplied by a -1, then it's a reflection in the y-axis. If there's a negative sign in front of the radical sign, then it's a reflection in the x-axis. If you're multiplying the inside by a number that's greater than 1, then it would be a shrink by the reciprocal. So if you see a 3, it's a shrink by a factor of 1/3. If x inside is being multiplied by a number in between 0 and 1, then it is a stretch by the reciprocal. So in this case, it would be a stretch by a factor of 2. If the number in front is greater than 1, then it would be a vertical stretch. And if the number in front is less in between 0 and 1, then it would be a vertical shrink. So these are horizontal stretches and shrinks. These are vertical stretches and shrinks. Alright, so let's just practice some out and talk about graphing some more. So we have graph g of x equals negative square root of x minus 2. And compare the graph of f of x to the square root of x. So this is where we're going to talk about our transformations, our stretches, our shrinks, our reflections, and all that stuff. So to graph this, the first thing I'm going to do is figure out what the domain is. So I am going to put what's inside of the radical sign, greater than or equal to 0. So I find that x has to be greater than or equal to 2. So that's my domain. So I'll start with 2. And then remember that I want to have some perfect squares in there. So if I put 2 in there, it'd be 0, which would be good. -0 is still 0. Now I'd want it to be 1, that's the next perfect square, so I'd make it 3. And then if you wanted to make it 4, well then you would make x 6. And then the next thing you'd want to make it, if you wanted to go another one, would be 9, so you'd make x 11. Now this is a pattern that we didn't really talk about last time, so I was just introducing it. But notice what the x is going up by here. It's going up by 1, 3, 5. If you remember quadratic functions, our y values went up 1, 3, 5. Remember the 1, 3, 5 method. So the same thing's happening here, it's just instead of y is going up by 1, 3, 5, x is going up by 1, 3, 5. So it's kind of like the inverse of that function. So that's just something to look at. And the reason that's happening to 1, 3, 5 is because x inside of here is being multiplied by 1. There's 1 there, so that's why it's 1, 3, 5. Not that you have to know that to graph it, but it could help you. So if I made x3, I would have the square root of 1, which is 1, make it the opposite of that, so I have -1. If I plug in 6, that would be square root of 4, which is 2, and the opposite of 2 is -2. And then that would be -3. Alright, so I'll go ahead and I will graph this. So 2, 0, 3, -1, 6, -2, and 11, -3 I can't graph, so I know I won't go past the -3. And it looks something like that. Okay, so now we're going to compare the graph to the graph of f of x equals the square root of x. So the negative sign in front means that it is a reflection. And that is in the x-axis because it's in front. Then after that, it is subtracting 2 inside, so that is a horizontal translation. Right 2 units. Alright, so there you go. That is the comparison to the graph of f of x equals the square root of x. Alright, so now on the next page we have a few for you to try on your own. So try these three out, compare them to the graph of f of x equals the square root of x. So all we're looking for here is the transformations. So pause your screens and give it a try, and when you play, you will see the transformations come up on the screen as I talk about it. Okay, so for number 1, we have x is being multiplied by 1/4. So since x is being multiplied by a number that's in between 0 and 1, that would be a horizontal, because it's inside, right? So it's a horizontal. Now is this stretch or a shrink? So remember, when it's horizontal, we take the reciprocal, and that's the factor. So the reciprocal of 1/4 would be 4. So since the factor is 4, that would be a horizontal stretch by a factor of 4. So that is for number 1. Whoops. For number 2, here we are subtracting 6 outside of the radical sign, which means that is going to be a vertical translation. And since we are subtracting, it's a vertical translation down 6 units. For number 3 here, we have a negative sign in front of the radical, so for that we know it's going to be a reflection in the x-axis. And then the 3 on the outside means it's also going to be a vertical stretch by a factor of 3. Alright, so these are the 3 transformations that we have here. Alright, for our next one here, we have let g of x equals -2 root x minus 3 minus 2. Describe the transformations from the graph of f of x equals square root of x to the graph of g, and then graph g. So, why don't you guys give this a try, describe all the transformations, press pause, and when you're ready, press play, and we'll go over it together. Okay, so for the transformations that we're going to have, there are a decent amount of them here. So the first one, the negative sign in front would be a reflection in the x-axis. The next one, we're subtracting 3 inside, so that would be a horizontal translation, right 3 units. And then we are subtracting 2 at the end, so also it is a vertical translation down 2 units. Alright, so that is all of the transformations. Now to graph it, again, to find out what the domain is, we would put x minus 3 greater than or equal to 0. Solve for that, so x has to be greater than or equal to 3. So x is going to be 3, and then if I follow the 1, 3, 5 method, it's going to be 3, 4, 7, and 12. And that will just give me the perfect squares. Not that I can't use other numbers for x, but they won't be perfect squares, so it'd be kind of hard to figure out the irrational numbers. So 3 would be 0, which would give me -2 once I do all the work there. 4 would be 1, so it would be -2 minus 2, which is -4. 7 would be 4, square root of 4 is 2, -4 minus 2, which is -6. Notice this is going down by 2, so this will be -8. I'll go ahead and graph 3, -2. 4, -4. 7, 6. And 12, negative 8, so I know that's going to be over here somewhere, so just kind of use that for the direction of the graph. And it looks something like this. Alright, so that's all we're doing today. So there's going to be a couple of these on Big Ideas. So if you guys just want to go ahead and practice that, and if you have any questions, please reach out and let me know. Alright, thanks guys. Have a good day.